In this lesson, we're going to look at Descartes' rule of signs. Descartes' rule of sign tells us how many positive and how many negative real zeros a polynomial has. To use Descartes' rule, just count the number of times the sign changes between each coefficient in a polynomial. So arrange the polynomial in order and then count how many times our sign is different as you go along from largest to smallest in the terms of the polynomial. So count each time the sign is different. Before you count, arrange in order. We've already said that, but let's say it again. Once we count the sign changes, we can say that the number of positive real roots is either equal to the number of sign changes in the function or less than the number of sign changes in the function by some multiple of 2. And the number of negative real roots is either equal to the number of sign changes in the function if we have used negative x or less than the number of sign changes in p of negative x by some multiple of negative or multiple of 2. What that means in plain English is in the original function, and that's this one, we would line them up and line up terms and count the changes. In this one, we would plug in the value of negative x, just negative x, and then simplify and count again. And then after you've done that, this part right here, what it means by or by some multiple of 2, it means that you're going to have more than one answer. So when you get your result, when you count your number of changes, it means that you're going to subtract by 2 until you get down to 1 or 0, because if you get to 1, you can't subtract 2 anymore. So for example, if the number of changes, if we change 6 times, so for example, if we have 6 changes, we would say six or 4 or 2 or 0 roots. Or if we have 5 roots or 5 changes, we would say we have 5 or 3 or 1 roots. So I'll go ahead and show you what this looks like in an example. Let's take a look at f of x equals x to the 5th minus 2x cubed plus 2x squared minus 3x plus 12. First of all, how many roots are we expecting? Because this has a degree of 5, we are expecting 5 roots. So we're going to be looking for 5 roots to begin with. All right, that's how many we're going to have in this polynomial. In our first term, we're positive. Our second term is negative. Next term is positive. Next term negative. Next term positive. This is what we mean by looking for sign changes. So we go from the first term to the next term and we ask ourselves, did I change signs from the first term to the second term? So because the first term is positive and the second term is negative, I would say yes, I changed signs. Then I go from the second term to the next term and I ask myself, did I change signs? Yes, because the second term was negative and the third term was positive, so there's a sign change. Do the same thing again, going from the third term to the fourth term. Positive to negative, yes, that's a sign change. And the last term, fourth to the fifth term, there's another sign change. So by sign change, just to make sure we're clear, everybody knows what I'm looking at here, I am looking at what's in front to right here. That's a sign change. They're not the same thing. So then I'm looking from this one to this one. So negative to positive. And then I'm looking here, and then I'm looking here. All right, so I'm looking at the sign changes. So I would say here, regarding my positive roots, I would say there are 1, 2, 3, 4 roots. I would say there are 4 or 2 or 0. So I keep subtracting 2 until I get to 0, or 1, but because I started with an even number, I'm going to end up with 0. So there are 4 or 2 or 0 positive real zeros. So now I'm going to do my negative. And in order to figure out my negative zeros, I'm going to calculate f of negative x. And to do that, I'm going to rewrite my polynomial, and everywhere I see an x, I'm going to put a negative x. So I'm going to put negative x. I have no idea why I just wrote an 8. Really, I don't. I think because I was looking at something else and I saw an 8. So I'm going to put negative x to the 5th. And I'm going to write minus 2, and then negative x to the 3rd, plus 2 negative x to the 3rd, minus 3 times negative x plus 12. So the thing to think about here is what happens when we see these exponents. So remember, if you have an odd exponent and you're taking a negative value to an odd exponent, you're going to end up with a negative result. So like, for example, negative x cubed. Let me do that over here to the side. If I take negative x times negative x times negative x, these two become positive, but when I then multiply this one times this one again, I end up with a negative result. So anytime I have that odd man out over here, it negates my answer, so I get a negative result. So negative x to the 5th equals negative x to the 5th, so there's a negative answer. Negative x cubed becomes negative x, so negative x times negative 2 becomes positive 2x cubed. All right, the reason for that, if you're not sure, because this was negative 2 times negative x cubed, okay, and that means it's a plus, so negative times a negative. Negative x, this was a squared, that should have been a 2. Negative x squared, negative x times negative x becomes a positive x, so that can stay positive 2x squared. Negative x times negative 3 becomes positive 3x, and then plus 12. So now I can count my sign changes. So I should have negative x to the 5th here to a positive, so yes, there's a sign change. From my 2x cubed to my 2x squared, there is no sign change. To the next term, the 2x squared to the 3x, there is no sign change. And between the last two terms, there is no sign change. So I have I only had one sign change. I have one negative real zero. So what I want to do now is think about what my combinations of zeros are. You won't generally or always be asked about this or to set it up like this, but I like to see how they can be laid out so that I can see what I'm going to have. So I just like to make a table and see how what my combinations of roots can be. So I can have positive roots, negative roots, and I can have imaginary roots. Remember, these guys have to come in pairs of 2. So the only way I can have those is if there are multiples of 2. I have to have a total of 5 roots at any time. So I can either have 4, 2, or 0 positive roots. So if I have 4 roots, I can have 1 negative root. That leaves me with the possibility of no imaginary roots for a total of 5. I could have 2 positive roots, and if I have 2 positive roots and I have 1 negative root, I've taken up 3, then I could still have 2 imaginary roots. That would give me 5. I could have 0 positive roots and 1 negative root, that means I would have to have, in that case, 4 imaginary roots for a total of 5. And those are the only combinations left that I can have. Okay? Let's look at another example. So I have 3x to the 5th plus 2x to the 4th minus 5x cubed plus 4x squared plus 6x plus 7. So I'm going to be looking for 5 roots. Let's start with the positives. So here, no sign change. Yes, I have a sign change. Yes, I have a sign change. No sign change, and no sign change. So I can have 2 or 0 positive roots. Next, let's look for the negative roots, and to do that I'm going to need to plug negative x in and evaluate at negative x. So f of negative x would be 3 times negative x to the 5th. So I'm just going to go ahead and drop that down. I know that's going to be negative 3x to the 5th. And then I'm going to have plus 2 times negative x to the 4th. An even exponent is going to make that a positive x, so that's going to remain a plus 2x to the 4th. And then I'm going to have minus 5x cubed, or negative x to the 3rd. So that's going to be a negative x to the 3rd multiplied times this minus 5, so I'm going to have plus 5x cubed. Then plus 4 negative x squared, that's going to become positive x squared, that's going to be plus 4x squared, plus 6 plus 6 times negative x. Down here we're going to end up with minus 6x, and then plus 7 plus 7. So now I can check my sign changes. So I'll have a minus here to a plus, so yes, I have a sign change. No, I have no sign change. No sign change. Yes, I have a sign change. And yes, I have a sign change. So we're going to have 3 or 1 negatives, zeros. Okay, so that's how that one's going to lay out. So if I'm going to do my table of roots, I will have, let's see, let me make a little more room here. I will have make some room. I can either have positive, negative, or imaginary roots. And again, I'm going to have a total of 5. So if I have 2 roots that are positive, and I combine that with 3 negative roots, I should have 0 imaginary, because my total has to be 5, so that works. If I have 2 roots and 1 negative, then I've taken up 3, I can have 2 imaginary, so that gives me 5. If I have 0 positive and 3 negative, then I can have 2 imaginary, so there's my 5. If I have 0 positive and 1 negative, then I can have 4 imaginary, and there's my 5. So those, I think, are all the combinations that I can have, and that takes up all the combinations of my roots. All right, let's try one more. I think, oh, this one's short. 3x cubed minus 2x squared plus 6x. So this one, for my positive roots, I should have, here, we're going to have a sign change. Here's a sign change, and here's a sign change. So for the positive roots, I'm going to have 3 or 1 positives. I have 3 roots total. For the negatives, let's do f of negative x. So I have 3 times negative x cubed. So that's going to become negative 3x cubed minus 2 times negative x squared. So that's going to become a positive, so it's going to be negative 2x squared. And then positive 6 times negative x, that's going to become minus 6x. Oh, look what's happening here, which is minus 4. Doesn't look like I'm going to have any negative roots. So no sign change. Nope. No sign change. No sign change. So no negative roots. 0 negative roots. No negative real roots, sorry. So if I were going to make my table, which you don't have to do unless you're asked to, I don't know, maybe Professor Dodson might ask you to do that on a test. If you have 3 positive roots, maybe it'll be a bonus question or something, I don't know. And 0 negative roots. You'll only have zeros in this negative column. You would have 0 imaginary roots because they have to come in pairs, and you can only have a total of 3. And you might have 1 positive root and 0 negative roots and 2 imaginary. And that would be it for that table. And that is how you use Descartes' rule of signs.